Hello everyone, my name is Mohammed Hussein. I'm super happy that finally I decided to start my channel. And the first session is learning the ROS. Actually, I'm planning to give you some introductions about the ROS robot operating system practically. But before that, I would like to give you some very short introductions about myself. My name is Mohammed Hussein. Originally, I'm Iranian and I have a PhD in the control in the electrical engineering by focusing on the robotics, control of the robot actually, and master in the mechatronics. And I have a postdoc also in the robotics. So most of my background in the academic back to the robotic knowledge, but also I have a good experience and knowledge as a software developers. Um, this is a very short introduction about my background. So sometimes I feel that I have some kind of the knowledge in the robotics. That's main reasons that I decided to create these channels to share my knowledge, my experience in the robotics. But there is one another point that I would like to share with you, and it's that as you know, and probably as you understand from my accent, my English is not my native language. So I'm speak my native language is Persian, and sometimes it's very difficult to actually make a lecture in the English because I think in the Persian most of the time I speak in the Persian. So, but finally I decided to speak to have some kind of the channels in the English. Uh, mm, by the way, I think most of the people that will probably follow me are engineers and they know the coding or something like that. So we try. Actually, I have to. If it would better to say that I will try to do my best to sharing my knowledge in English. So without wasting the time and just by considering these short introductions, let's to uh, jump to the ROS to know that what exactly the ROS. Uh, Here we have a Google. Probably you know about that. So we can ask the Google, please find. No, Google is not ChatGPT. You have to write something. You have to touch the keyboard and ROS. Type the ROS, but ROS is not a flowers. I promise you, ROS is operating systems. Yes, this is the main page of the actually ROS in the official website of the ROS, but there is something here. ROS, Robot Operating Systems. Uh, it's not true. ROS is not operating systems. Don't panic. I will explain more. But to now, just I wanted to let you know that the ROS is not operating system. It's a middleware software, but I will explain more in details. Just a bit of scroll down. Here you can find a lot of videos in this website. If you have a time, you can take a look at them. But there is some other links that are very important, especially for us for these meetings, and is about the documentations. There is two other links such as the Stack Exchange and the forums. If you know about the Stack Overflows or something like that, there is some kind of the website that you can go there, sign it, and you can, if you have any questions, you can put your question there, and some other developers come to answer to your question. Is something that exactly happened in the Stack Exchange and the forums. But here we want to go to the documentations. Inside of the documentations, you can find a lot of documentations about the different distributions and the versions. Two words, please remember: distributions and the versions. What exactly mean? Because you see that okay, we have some kind of a distribution, Jazzy Jaliska for the ROS 2. And if you scroll down a bit more, here, for example, you can do a lot of other documentations for the, for example, ROS2 for this distributions, or especially ROS1 for the another distribution or something like that. So just let me explain and clear something here at this point. We have two kind of the main version for the ROS1 and the ROS2. The long-term support is the ROS one is, I think, if I didn't mistake, is 2025. So after this year, there's no support from the Open Robotics. Open Robotics is actually the main company that maintain the ROS. ROS operating systems is actually open softwares that you can download it, you can use it. But it's not only the products for this company is actually support the ROS, and also they actually ROS support the, maybe you have hear about the some one product called Gazebo. This is a simulator for the ROS. We can use it in the future. But here we have a Open Robotics ROS Gazebo, and then now we are using the ROS version number 2. And this is a version that we are using. So for actually, let me for these sessions, actually for this I mean that for these courses, I consider that they're using the Jazzy Jalisco. This is some kind of the last version of the ROS number 2 and we can install it on the Ubuntu. So if you click on the documentations, then then you actually we have a documentations for the ROS 2 for the version of the Jazzy Jalisco. There you can find a lot of other sublinks here that we can click on it and to learn more about what is the Jazzy Jalisco, how can, for example, installations or something like that. Here you can do a lot of informations. For example, how can by these instructions, how can you install for the Ubuntu Linux, how can you, for example, for the Red Hat, how can you install on the Windows, and some other informations. But I think for the next video we will talk about how can we install the ROS in our computer. But before that, let's take a look at the more details about what exactly ROS and how the ROS help us to develop our softwares, especially for our robots. So I would like to ask you to join me to take a look at my notebooks, because I really like to have use the pencil and the pen to write something. That's why I choose the name of my channel as a Robotic Notebook Science, RNS. So I would be happy if you can subscribe, and if you during the actually these sessions, if you have any questions, please comment out for me, and then I will do my best to answer all of them. So let me open my notebook. Okay, here, as you can see here, I provided some general informations about the history behind of the ROS, but probably you can, by just very simple search, you can find it. So I have no plan to go more in details. For example, in 2006, the group of the engineer, they established a company called Willow Garage. They decided to standardize the programming for the robotic systems. So they developed they introduced a version of the ROS, call it the ROS 1 or Sea Turtle. This is a one very, very small point. Each of this version of the ROS has a special name. For example, we know that the ROS 1.0 as a Sea Turtle, or ROS version 1, actually subversion of 11, we know that as a Neotic. So each of the version has some kind of the name. And also, for example, here for the ROS 2, we know that as a Jazzy Jalisco. But then the real version, in terms of that regarding the number, is 210, something like that. And let's back to the Willow Garage. Yes, in 2012 they decided actually to extend the company. They opened another company called Open Robotics. In this company, they also try to maintain and develop more softwares and maintain the softwares such as a ROS and Gazebo that I have mentioned. That is a simulator for the robotic systems. And finally, they decided that in 2017 they introduce ROS version number 2. Of course, that there are some requirements behind of these decisions. They wanted to introduce the new version of the ROS. For example, ROS 2 is real-time. ROS 2 is a cross-platform. It means that, for example, in the ROS 1, you can only install the ROS 1 for the Linux. But ROS 2 is a cross-platform for it, as already mentioned, that you can actually install on the Windows, on the, for example, Linux, or even in the Mac. So by this information, first you have to remember that the ROS is not operating systems, because you have to install on some kind of the operating systems, but is a middleware. But what exactly the ROS? How can we use the ROS, and why we have to use the ROS? To actually to answer to these questions, first let me to give you a very another short introductions about the closed loop systems in the robotics. Actually, each of the robotic system, usually, not always, usually have some kind of the closed loop system. We call it closed loop system because we are using the sensor to read the function of the robots and the feedback, and we call it this feedback as a closed loops. What is the sensors? Of course, that you know that by the sensors you can actually read the some of the functionality of the robots to the some kind of the measurable signals, such as the electrical signals, or for example some kind of the data. And what is the controller? By the controller you can make decisions. For example, here we have a desired inputs, and we have some kind of the output from the real performance of the robot. And here, for example, the differences, we call it error. And according to this error, we make a decision what exactly the next best signals that we have to provide for the, for example, the actuators. And the actuators is responsible to convert the signals to the some kind of the real, for example, phenomena such as the force, torque, or something like that, in order to move the robots and to follow our desired performance. This is a very simple actually structure of each of the robots as a closed loop systems. But as you know that, and as you can see here, each of the part of the robots, for example, you can develop all of these part of the robots in the computer of the robot. For example, if you, for example, already used by some kind of the industrial robots such as the KUKA, or from the KUKA company, or from the ABB, you can see that in actually close of the robot there is some kind of the case. Inside of the case there is exactly a real computers. So there are different scenarios, but one of the scenarios is that you can develop all of them in the computer of the robot. For example, you can connect the sensors, connect the actuators, connect the controller to the computer of the robot, and implement everything inside of the inside of the computer of the robot. So each of the 6 sections need to talk to each other, need to transfer, need to actually exchange the informations between a different part of the robot, sensor, actuator, and controller. How can we do it? Here we have very simple architectures for the robots, including sensor, control, and actuators. You can consider as some kind of architectures, and each of the actually this we call it, for example, the application layers, and we have operating systems, and we have actually a hardware. CPU memory is exactly that, the hardware that we are using in the computer of the robot. And also we have some kind of the here, for example, we have sensors, we have actuators. Each of the sensor actuators, for example, from the one side is connected to the real physical sensor. For example, here we have sensors, and then we have an interface, is some kind of the driver sensor that is responsible to read the data from the sensor and convert it to some signal. For example, measurable signals such as the data, or by the USB or something like that, by some kind of the normal port connected, this output of sensor connected to our computers by the, for example, the USB or something, transfer data to my computer. Or we have the same scenario also for the actuators. Here, for example, in the one side of the interface, our driver of the actuator is connected to the real actuators, such as the motors or something like that. It can be a DC motor, or another, for example, brush or brushless motor. What happening inside of our computer? All of this information should be, for example, transferred to our software packages that we develop for our sensors, because we need to develop the software package in order that we read this data and, for example, analyze data, or by some kind of the filter, remove the noise of this data or something like that, and then provide this data, for example, for the controller. And in the controller, as I already mentioned, we make decisions, and then we provide some signals for the actuators, for example, to receive this data from the controller and provide some kind of the real signals for the actuators and send all of these one to the actuators. This is some kind of the flow happen when we are running sensors, actuators, and our controllers. And this is complex because all of these actually sections of the sensors, control, actuators need to transfer data. Here, the ROS is coming. ROS mentioned that, okay, I'm a ROS. What will happen? We have a ROS here. Oh, let me. We have some kind of the ROS here that is on the top of the operating systems. So it's a middleware software, and we develop our packages for sensor control and actuators in order that they can, for example, based on the ROS structures, ROS standardized. So when we create a package, we create a package according to the ROS. So each of the package can, for example, transfer and exchange the informations using the ROS. No need to actually connect it directly, each of the software packages to each other. Just we have to use the ROS to exchange the data between the different packages. So one of the main application of the ROS is provide a communications structures for our different packages that we developed. So it's help us to have a good communications between the different packages, having very nice synchronizations and scalability and reusability. What exactly means? I mentioned that, for example, if you have another sensors, for example, you want to add another sensor, you don't need for example, to create another communication between the sensor and controllers. Just if you have a ROS, here, just you have to connect your another sensor to the ROS. So ROS handles everything. So you no need to worry how the new sensor communicate with the controllers because the ROS provided for you. So this is something that happened about the scalability and about the reusability, and also is a very easy. If you develop your sensors or controllers, for example, you develop a controller for the robot 1 based on the ROS, and if you want to use this controller for the robot 2, if you know that the robot 2 also is developed based on the ROS and using the ROS, so you can easily take the controller from the robot 1 and transfer to the robot 2, and you will expect that the controller also is working in the robot number 2. This is about the reusability. This is some kind of the main application of the ROS. So, but for only in the one meetings, I don't expect that you have a good knowledge about the ROS, what exactly ROS or something like that. This is a very, very short introductions, but we have to see more in detail, especially practically, how can you use the ROS. And probably in the next meeting, after the next meeting, when we started to create a package and the node for the ROS, because next meeting just we want to install the ROS, you can have a better view actually. So by these short introductions, we can close these meetings and see you